Welcome to the Apigee Up Close webcast. I'm Keith Danekind, and I'm a customer engineer on the Apigee team. Here's our agenda for today. I'm going to do a brief overview of API management and Apigee Edge, and that's going to be in the context of how API management can be used to help you modernize a legacy application to enable new digital experiences. We're going to do a demo and look at a specific use case where we take an old service that speaks XML running on legacy, and we're going to port that up to the cloud and convert it to JSON. And we'll look at everything that comes with that and how Apigee will help with that. At the end, we'll do questions and answers. So let's jump in. So what is API management and what is Apigee and how might they help us? Let's look at life before API management or without it. What we see on the right-hand side here is a typical retailing environment. So back end for a retail environment, there's different clients that you might use to shop with this retailer. There's a mobile application, a web application, and then there's a point of sale system inside the store. The customer has three different experiences depending on whether they're using mobile, web, or whether they're shopping in the store. And those different applications have lots of different connections to the back end. And there's a bit of chaos going on here. The experience, as you might imagine, is not that great and inconsistent from one to the other. If you buy something in the store, you can't see that purchase on the web or mobile and things like that. So the customer is left wondering. They don't have a very good experience. The developer who has to write applications for mobile, web, or point of sale has a very hard time. That person has to think about all the different ways you might authenticate with these different backend systems, all the stuff it would take to integrate with them. Chances are they have very different looking services and the way you speak to them could be very different. The IT team is kind of stuck in the middle. So they're forced with maintaining all of this and they're trying to deliver a good customer experience and support those developers. And that's a challenge. If we look at this with API management, how might we improve it? So let's leave the back end the same, but let's stick an API management platform in front of this, something like Apigee. And what we're going to do is develop an external facing set of services. And these are all going to be consistent. So while they don't exactly match what's on the back end, they're going to be consistent with one another so that a developer who's using this is going to find this very easy. If you use one service or the other, they're going to be very similar. And authentication will be the same for all of them. Things are better for the IT team also. They have the same systems to support, but the outside consumption of these is going to be much better. They're going to have a lot more visibility into what's going on with those services, and it's going to be much easier to onboard new applications. And we'll see why later on in my demo. The customer is going to get a good experience. We can make the experience consistent among mobile, web, and point of sale. So what might this look like? Let's consider we've got three applications over here on the left, and we've got some services over there on the right. Some of the services are running inside of a legacy system, monolithic applications, maybe speaking SOAP and XML, and REST and JSON. There's multiple authentication processes, and they don't necessarily scale real well. And moving to the cloud at some point is a goal. On the cloud side, there's modern microservices architectures. There's REST and JSON. There's OAuth authentication via an external identity provider. The services can scale on demand, and new services are going to be created there. So how do you mix and match these two together to provide a great experience for these three different applications? In the middle, we're going to have Apigee. We're going to extend what I started on the last one, and we're going to have a set of APIs, and that's what we want to share with the outside world. We're going to map those CRUD operations, create, read, update, and delete, to the HTTP verbs. So I'm going to call with post if I want to create something. I'm going to call with put if I want to update something. And that's where Apigee is going to help us out. Some other benefits we might get. We can enable the application developers. We have a nice portal for those folks, and we're going to be much easier to write new applications. We'll provide a consistent, well-designed set of interfaces to the outside consumers, and we're going to control access to the backend services. We'll rate limit to protect backend services. We'll impose quotas per application, add caching to help performance, reformat the request, reformat the response, manage the keys for all of these different applications, and collect usage analytics to help tune the whole program. So those are all different things we can do by inserting API management into this picture. This is a picture of what an architecture might look like. A lot of folks have things in all kinds of different places. They might be in VMs, might be running on premises, might be running in the cloud, might have some serverless in there. They're moving towards a service mesh. All of these things have to be managed. And at the top of this, all of these applications need to call into those things in one way or another. Putting API management across the top in the red layer there makes a lot of sense. So it's going to act as the facade to make all of this look consistent. It's going to allow us to move things from one place to another without disrupting all of those applications. Apigee is going to give us 3 deployment options. There's a public cloud SaaS offering where Google's going to run everything for you in the cloud. There's a hybrid offering where a lot of it's going to be running in the cloud, but some of the networking components and the things that route traffic are going to be running with the computing resources. And then there's private cloud where the customer can manage the whole stack and put it wherever they need it. Running a full API program requires full lifecycle API management. We've got to consider the entire life of an API. Designing it, developing it, securing it, publishing it, scaling it, monitoring it, analyzing it, monetizing it, and everything else that comes with that. All of that is required to run an effective API program. Gartner does an analysis of this space, and they talk about full lifecycle API management, and they state that that's what's required if you're going to run an effective API program. In their latest analysis of this, Gartner placed Apigee in the best spot in there in the upper right-hand corner. There's a wide variety of customers who use Apigee, and they're in all kinds of different businesses. Some are new companies that are digital natives. Some are 100-year-old companies. What they all have in common is that they've seen a pattern that makes them successful. And that pattern is thinking about the end user and working backwards towards the systems, rather than thinking about the systems and working out towards the end user. We think of this in terms of thinking outside in rather than inside out. So what it looks like is first we consider the end user, and we think about what's the best way to provide a great application for that end user, and what would happen if that user had a great set of applications. It would mean that we've got to enable developers and partners to be able to write those applications. We need to make it easy for those folks to do this and give them everything they need. And that means having a great set of APIs. And to have a great set of APIs, you need an API team who's going to think about what should we expose as APIs? How should they be managed? How should they be documented? And things like that. Thinking from the outside in, from the end user's perspective back towards the legacy system, is the change that a lot of our customers have had that has made them most successful. So let's talk about how to modernize a legacy service. I've built a basic order status service. This is the current state of it. So you call in the URL and you call order status, and at the end of that, you stick an order ID. And a response comes back and it tells you the status of the order. What was the order ID? What was the date? Who was it sold to? What's the distribution channel? What's the assignment reference, the sales group, the status, and the ship date? It's currently running on premises in a legacy environment, and there's a goal to migrate it up to the cloud to a microservices architecture. So here's the problem with the order status service. It's running in a legacy system. It has its URL. We've got a number of applications over there, a partner application A, a partner application B, and an internal application C. All of those are using this service, and we don't want to disrupt it. We'd like to be able to move it straight up to the cloud without disrupting anybody. But there's a few more things, a few more goals that have come up in this process. So, of course, we have to move the legacy service to the cloud with no downtime. But we'd also like to add support for JSON format data. Currently, the service just delivers XML. We'd like to get visibility into which applications are using the service. We really don't know right now. There's a URL, people call it, but we really don't know who's calling it and what's going on. We'd like to add some rate limiting to protect the service. Sometimes one of these applications misbehaves, sends in way too much traffic, and it brings down the service for everybody. So we'd like to add some rate limits to protect the service. Also, add some call quotas based on the partner relationship. Some partners should be able to call more frequently than others based on their relationship with the company. There's some internal data that comes back with the service, and we like to remove that just for the partners. It's needed internally, but some of that data is a little bit sensitive, and we don't want it going out to the partner applications. We'd like to control access to the service and make sure we know who's using it and being able to control exactly what they're allowed to do. We'd like to make it easier to onboard new applications. Currently, it can take a month or two to create a new partner application and get services ready for those partners. And after all of this, we'd like to establish a reference architecture. So the pattern that's used for this service could become a blueprint for modernizing other things, and really just a better way of doing business moving forward. We'll be moving this from the legacy system to the cloud, but we'll be getting a lot of other things in there too, a lot of other benefits in there too. So we've seen that there's a lot of benefits to moving to this architecture and having an API management system in between the cloud, the legacy systems, and all those applications. What is the plan for getting there? Well, first, we're going to insert Apigee into the path as a reverse proxy. So The applications on the left are going to talk to Apigee, and Apigee is going to talk to the systems on the right. We're going to create products to control access, and I'll talk about that in just a minute. There's a way of grouping APIs together into products to control who has access. We're going to generate API keys for each application, and Apigee is going to manage all of those keys that the developers are using. We'll convert the legacy response that comes back from the legacy system into JSON. We'll start routing traffic to the cloud service a little bit at a time, so some applications will get migrated before others. We'll add a rate limiting policy to control how much this thing can call. We'll add a quota policy to limit partners. We'll return good error messages so that instead of seeing 500 something horrible happened, they're going to get a reasonable error message that's going to tell them exactly what's going on. And we're going to add a policy to remove the sales group from the external applications. That's the sensitive data that I was talking about. We're going to measure all the traffic flowing through here, and we'll know exactly which application is sending traffic and what's going on in there. And finally, we'll build a developer portal to make it easy to onboard new applications. So when somebody wants to write an application in the future, they're just going to go to a developer portal, and it'll be self-service. So that's the plan. I want to talk a little bit about API products because that's going to come up in here. API products is a concept that allows you to abstract API production from API consumption, and it provides a new value to the business. So it's kind of a new way of thinking about how to package up your services. What it allows us to do is we don't give somebody access to a particular API. We give them access to an API product, and that product can include some services. So it may include different things, different URLs, different things on the ends of the URLs. And we're going to create products out of this, and those products will have metadata associated with them. And that metadata might be things like the price, the quota, the rate limit, things like that. We'll generate some keys, and those keys will be used to access this system. And those keys give you access to one or more products. So we'll create keys, those access products, those products entitle us to certain APIs. In the order status demo, what we're going to do is we're going to have two different products. We're going to have one for internal and one for external. And we're going to create three different keys, one for each of the applications that I've shown in the picture here. For the first one, partner application A, we're going to use the order status external product, and we're going to throw some custom attributes on there. When we create a key, we can associate some metadata with that key, and then it's populated in Apigee when that key is used. So we're going to have test group equal to true and type equal to external, and we'll see what happens inside of Apigee based on that. For the second one, partner application B, we're going to use the order status external product. We're going to have custom attributes of test group equals false and type equals external. And finally, for the third one, internal application C, the product is going to be order status internal, and the custom attributes are going to be test group equal to false and type equal to internal. Okay, so let's look at a demo, and let's see what we're going to do in Apigee to make all of this happen. Okay, first let's look at our existing backend services. So there's two backend services. There's one that's running in our legacy environment. It speaks XML. And there's another one that's running up in our microservices environment. It's the new version of that, and it speaks JSON. So let's look at each of these and see how they work. So I place up here at the end of my URL an order number. And then when I call this, I'm going to get back the status of that particular order number. So that shows up down here. Our new service has the same data, but it's going to come back in JSON format. So when we do a request in here, we're just going to get back the same thing that's in JSON format. So we've decided that the external applications all want to speak JSON. They're all single-page web applications and modern applications, and folks aren't too interested in having XML anymore. So we're going to convert the old one to speak JSON, and that'll give us the luxury of being able to move over to the new one whenever we like, because the format's going to be the same. So let's look inside of Apigee, and let's see how we can make this work. So inside of Apigee, I've built a proxy here called appmod1. What we'll see in here is that I've created a new URL, v1 orders, and when we call this, it's going to send the traffic to this backend system that I've got specified here. If I click over here to develop, we'll see the details of what's in here. Let me give a quick tour of Apigee so we know what we're seeing here on the screen. So inside of here is a graphical depiction of a request and a response flow. And to that, I can add a number of policies that will affect that request and that response flow. When I first create this proxy, there's nothing in here. It's just a straight through forwarding of the request to the back end. and the response being forwarded back to the client through Apigee. It does collect analytics, and that's useful, but it's not changing the request and the response in any way. So we add policies to this to change the behavior. The policies that have been configured are over here. There's a proxy endpoint, which is a flow that happens between the client and Apigee. And then there's a target endpoints flow, and that's what happens between Apigee and the backend system. Right now, I've only got this connected to one backend system, so we only have one target endpoint. It's called default. Later on, I'm going to add more, and we'll see different target endpoints will pop up down here. We can have different logic per target endpoint. Up here, we add policies. So there's a number of policies you can add. If you want to add them to the request or the response, you hit the respective plus button. Inside of here, there's a number of things for traffic management, a lot of different policies around security, a lot of things for mediation. What I tend to do a lot inside of Apigee is going to be changing the message slightly. JSON to XML, XML to JSON, raise fault to return custom error messages, assign message to change the request or response in some way. Maybe I want to add a header or remove something from the request. Extract variables lets me pull something out of the request or the response. And then key value map operations I would use oftentimes to store credentials and things I might need to look up. Sometimes I'll use some of the extensions. If the built-in policies don't do what I need, I can write code in Java, Python, or JavaScript. I can call out to another HTTP service. I can reference another shared flow. So those are all different policies that I might use to build things inside of Apigee. So in my verify API key policy, I've put this in here, and this is going to make sure there is an API key that's valid. And if there's not, it's going to return an unauthorized error, and they won't get in. So in this case, I've told it to look for the API key in a header called API key. There's a spike arrest in here, and I've set the rate limit to 100 calls per minute. So these policies, all of the different properties in here can be set based on some variable that you want, or you can hard code them. I've set this to 100 calls per minute. The next two steps, I need an authorization header for the backend. So the backend requires an authorization header with some specific values in there. I'm going to go look up my authorization value in a key value map. So over in the administration section of Apigee, I've set a value in a key value map that's called secrets1, and inside of there is my authorization header. So I'm going to go look up that value, and I'm going to save it to a variable. And then in the next step, I'm going to take that variable and I'm going to reference it in here and create a new header. So I'm going to insert a header called authorization, and the value of which will be the variable that I got in the previous step. The curly braces indicate that this is referencing a variable. And that will make it so that the request can get into the back end. I've got some things down here to handle CORS. And that's about it for now. So a pretty basic flow. This is going to allow me to send traffic in and get it back. So here's our finished service running on Apigee. I can call that and I can get data from the back end. Now, what you notice in here, I've got a few different API keys. And if I call without that, it's not going to let me in. So I've got to have a valid API key in order to get in. And I've got one for each of the applications in here so I can test it out. So let's look at this. How do you get an API key? And what's necessary for us to be able to test out this simple service? So let's review the concept of API products. So an API product allows us to control access to a given API. So in this case, we have the store API and we have the catalog API. And we might do /store/location or /details or /inventory. Same thing on the catalog side with different features available under there. We may want to partition this out and decide which kind of access different people get. And we can do that by handing out keys, and these keys give access to one or more of these products. So the first step is to decide how do you want to control access to your set of APIs that you're managing with Apigee. So we're going to come up with two products in our order status example, and then we're going to generate keys, and those keys will give access to those products, and we'll apply some metadata on there also, and we'll see what happens to it inside of Apigee. So for order status, we've got two different products, and we've got some metadata, and we're going to generate three different apps. We're going to register three different applications, and that will generate keys that we can use to access those. And that's the API keys that you saw in the previous step. So let's look at how I did that. Okay, so when I was building this application, I came over to Publish over here, and I went to API Products. And I clicked up here to create a new API product. And there's some questions in here about the name of it, the kind of access you want, and things like that. So let's look at order status internal first. So this is the API product for the order status. I've set the quota to 50,000 requests every hour. I've chosen which resources it has access to. So it allows access to the AppMod1 API proxy. You can further constrain that with a path if you want. I didn't in this case. And we see down here a list of applications that are using this particular API product. Let's look at the other one. Order status external. Looks very similar in here, except the quota is different, 5 requests every 1 minute. And we've also got a custom attribute in here, type equals external. And what we're going to do with that is when the API key flows through Apigee, it's going to create a variable that's in scope for the duration of that request. And we're going to use that as a condition to remove some data from the response. And I'll go into detail on that a little bit later. But it's good to see where that comes from. There's 2 applications that are using this particular product. There is the order partner A and order partner B. If I click through on one of these, we can see how I created that. So there's a few different ways to create applications inside of Apigee, or register applications inside of Apigee. You can do it in here, where you're going to go in and just create an application, register it, and generate keys. Or it can be done through self-service in the developer portal. There's also a set of management APIs that you can call to generate keys. So if you want to automate that process and tie it into some other workflow you've got, that might be a good option too. In this case, I just created it in here. There is a key in here. And this is going to be the API key that I use. If I'm doing OAuth or JWT, I'd use the key and the secret, send those in, and that would be used to generate a token of some sort that I can then send through and have that validated. In this case, I'm just doing simple API keys to identify my application. So I'm going to grab the key, and that's what I'll use to send back and forth. You can set an expiration in here, or you can have it run forever. If this happens to get out in the wild, maybe somebody posts a question on Stack Overflow and accidentally includes this in there, you can revoke this key. So it's a nice feature of Apigee to be able to manage all of these keys and to have different expiration times and control what they can do and things like that. So that's where we get the keys. We created an API product, and then we registered an application. And when we registered that application, we get access to a particular API product, and we get keys. And those keys are used when we're making requests. So we have an API key. Let's go ahead and test this out. I like to use the trace utility to help me debug. So I'm going to come into here. I'll turn this on, and then we'll go send in a few requests, and we'll see what comes through. Let's send in a few. Let me turn off the API key so we can get a 401. Okay, that comes back with unauthorized as we'd expect. So let's look at what's going on over in Apigee inside the trace utility. So trace utility is really nice. It traces individual requests, and you can see everything that's happening in the system for each call. So for this particular one, we can see where the request came in. There's what we received. It enters into Apigee. There's a check of the API key. And this is what I was talking about earlier when I said there was some metadata and some variables that are created. So right when that key is processed by that API key policy, all kinds of data gets loaded in here. So these are all variables that can be used in your flow. So if you want to set the rate limit based on something in here, or if you want to use one of these as a condition to figure out how to route or something like that, they're all available to you. And this is a great way to see what's available in scope. So all these things are available in here. I can come through and I can look. I see everything that happens in here. And then I see, as this is handed off to the back-end system, exactly what the request looks like. And then we see the response that comes back from the back end. And there's our response in there in XML format. Up here where we got the 401, different kind of thing happening in here. So we see this big exclamation point on here. And that's the unauthorized error coming back. And this is the stock response that it gives. You also have the option to put a custom flow in here to handle this sort of error and return a custom error message if you like. So that's a nice way to see what's going on in here. This is working as I expected, so I'm going to go back and I'm going to add some more features. So I've added an XML to JSON policy in here. And what that's going to do is it's going to take the response that comes from the legacy system that's in XML. We're going to convert that over to JSON. Okay, let's test it out and see if we get JSON back when we send in a request. Go back to my testing application. And now the data is coming back as JSON. So that was one of our goals, was could we convert this to JSON to support those applications that are looking for that. So we got the basics completed. We were able to build a proxy that talks to the backend service and get the same answer back. And that's often a huge step when you're building this. It seems so simple, but basically just a hello world type thing to connect through and make sure it works and all the firewalls are open and things like that. So that's often the hard part. The other goal we had in here, beyond having just a basic service in here to control access to this thing, was to be able to move services up to the cloud. So what I've done in here is I've made a number of changes, and I'll review those with you. The first one was I added another target. So before I had just a default target down here, and that was pointing at the legacy system. I had clicked on here, and what I did was I specified a new URL and gave it a new name. And now I've got two of these. I have cloud and I have legacy, and each has different URLs. And so those are two different backend systems. We talk to Apigee, and then it'll talk to one of these. So I've added these two backend systems in here, each with their own URL. Inside of each of them is a set of logic. So we have different credentials for each of these systems. So we need to go look up the password and then look up the authorization code and add it as a header in here. And we'll do that in both of these. Those have moved out of here. They were in here before. This is the pre-flow. This is called no matter what we're doing, no matter where we're routing, or no matter what you put on the end of the URL. And then these are going to be conditional. So the other change in here was to add some route rules. So we have these two different target backends. We can use route rules to make decisions about which target should be routed to. So if you come over to here where it says default, you can see all the XML that's hiding behind the flow that was up there. And if we scroll all the way down to the bottom in here, we'll see what I did. So there's a concept in Apigee called a route rule. And what it does is this is logic that'll allow you to select a target based on some condition. So in this case, the condition is that there is a piece of metadata hanging off the API key called test group. And if its value is true, then the traffic will be routed to the cloud endpoint. And otherwise, in all other conditions, it'll be routed to the legacy environment. So verify API key is the policy, and then the name of it is verify API key.testgroup. So test group equals true is a piece of metadata I put on the key. Let's go back and revisit that so we can see where that came from. So some API keys will have this set to true and some will not. Let's go look at how that happened. So if we come over to publish and we look at our apps. So I decided the partner A application should get routed to the new cloud environment. So what we'll see down here is there's a custom attribute on here, test group equals to true. And I can come in and edit that set to false and it'll no longer be routed there, any traffic that comes in with it. So that's where that came from. And then when we are looking at the actual API, so we have a route rule that will take all the traffic coming from that application because it's associated with that particular API key, and it'll send it to our cloud URL backend. So we have two URLs showing up over here. One of them is the legacy XML backend, and the other is the new one that is JSON-based and running in the cloud. Let's run the trace utility, and let's see what this looks like. I've started the trace utility. Let's send in some traffic. So let's see what it looks like if we send it in with the first API key. So good, we're getting back the exact same answer, which is nice. Okay, so that's working as expected. Let's look at a few other changes I made to the API proxy. So we now have conditional routing. Based on API key, things will either be routed up to the cloud or to the legacy system. The next thing I did was I added a JavaScript function in here to remove the sales group. So there's a sensitive piece of information in here, sales group, which sales group handled this particular order. We don't necessarily want that to go out to the partners. So what I did was inside of here, I've added a JavaScript function that will take that response that comes back and remove that piece of data before sending it to the back end. So you can click on here and you can say JavaScript policy. and then you add that in there, and you can specify a new file, a new script, and then it'll create a file for you, or you can upload JavaScript if you already have it. And that shows up down here. So here's our JavaScript file. So if I click on this, we see it's referencing remove salesgroup.js. And if we look at that, pretty simple piece of Java code or JavaScript code. What's happening in here is we're creating new response, and new response is basically the old response being turned into JSON. So we're taking the text of the response that comes from the back end, running it through the parser, which will convert it into JSON or into an object in JavaScript, and that's assigned to new response. Then we say delete new response.order.salesgroup, and that'll remove that field from it. And then we take the new response and we turn it back into a string, and we assign that to the response variable. So context proxy response.content is the response that's going to go back to the client. And that's how this works in JavaScript. So just 3 lines of code in here, and the bulk of it is just removing this particular field. The next thing to look at is how do we do reporting on this? So we see that some of the traffic is going to the cloud and some of it's going to the legacy system. How do we know how much is going to each, and how might we report on this? There's some great features in Apigee to give us reports. If we go over to the Analyze section over here, we can see that there are a number of basic reports that are built in. We can come in and just see basic traffic that's flowing through here and see what that looks like. So there's our traffic for the last little bit, and we can see how it's flowing through here and which things are getting requests. I've created a custom report. Let's take a look at that. So under custom reports here, I've created the order status test traffic report. Let me hit edit here so we can see what that looks like. So what I did was I picked traffic, and I want to see traffic broken down by 2 different metrics. I want to see traffic by target. So what's going to cloud and what's going to legacy. And then if we click through on that, I want to see which developer app is responsible for which proportion of that traffic. So let's close this and let's run the report and see what it looks like. Okay, so in the last hour, what we can see is that we had 598 requests routed to legacy and 187 routed into the cloud. If we click through on here, we'll see that there's the internal application and there's partner B, and they're both routing to legacy, and we can see that they have about the same amount of traffic, well, exactly the same amount of traffic in this case. So you can add all you want to these reports, make them as detailed as possible, look at anything you want in the request and the response, and they'll give you a great visibility into what's happening in your system. You can use them for simple things, just like who's on version 2 and who's on version 3, or more business-oriented things like what are your shoppers buying and things like that. So that's a custom report, and it shows us the proportion of traffic going to each system. The other thing I did was to publish a portal. So I've created a portal for here, and that's going to help external developers who want to start building applications get up to speed quickly. So you can specify your pages in here, how you want this thing to look. I took the basic out of the box one and did just a few modifications just so you can see an example. So if I'm an external consumer of these APIs and I want to start using this, you would send me here. You'd send me out to here, and I'd come into APIs and I would see the order status API. And from there, I can get some decent documentation about how this works. I see what I can send into here, the fields I would expect to get back, the kind of errors I might get if something goes wrong, and then I can even try it out in here. So I can put my order numbers in here, and I can send that to the back end and actually try this out. If I sign into here, I can apply for credentials, and the API products that have been published are available to me, and I can choose one of those, and then it will generate keys for me, and I can start making calls. So as a consumer of this API, there's no meetings or anything like that. I can just get going, and I can be productive immediately because I have this nice developer portal to empower me. I can download the spec, and I might use that in some other tools to build client applications and things like that. So that was a quick example of how we might take this order status service and move it from the legacy system up to the cloud. What we saw in there was first we built an API proxy to route the traffic that's going to the legacy system through Apigee. And then we could implement some security asks for API keys, divide it out into some products and hand out some keys and things like that. We eventually moved it up to the cloud, or some of it, so that some of the calls coming through there were routed to the cloud. And we just took the partner application A, we routed that to the cloud. Eventually, once we're confident that everything's working, we'd route all the traffic to there by changing the attributes on those other two keys. And then all the traffic would be routed up to the cloud, and we could eventually retire that legacy system. So we had some goals. Move the legacy system to the cloud with no downtime. That was pretty easy to do. We added support for JSON format by dropping that policy in there to convert everything into JSON. We got visibility into which applications are using the service because now we have these API keys and they identify applications, and we can see that in the analytics system. We added some rate limiting to protect the service, so one system can't call too much and bring everything down. I added some quotas in there. I didn't demonstrate that, but I added a quota in there, and if you call too much, it's going to shut you down also. We removed the internal data from the partner application, so the response that came from the legacy system included a sales group. We put some JavaScript in there to remove that. We implemented products and keys, and that controls access to the services. And we made it easy to onboard new applications by providing a developer portal that gives simple documentation and the ability to add credentials in a self-service way. All of this helped us learn a lot about how we might do this with a service. And that could help us to establish a reference architecture for how we might move other services to the cloud and how we might get to the cloud quicker. Okay, so we're going to take some questions now. If you've got questions, go ahead and enter them into the question tool. I'll read them here and I'll read out answers. So we'll give that just a second. Looks like I've got a few on here. There was a question about GraphQL support. Does Apigee support GraphQL? We don't have formal support for it yet. It's something that's on our roadmap. There is a nice example out on community.apigee.com. Just search for GraphQL out there and you'll find a nice article. There's some sample code and a nice write-up about how you might support GraphQL with Apigee. Question about, does it matter if the test group is set to true or false? It does. So if it's set to true, then they're going to be routed up to the cloud. And that's the criteria. So the key that I generated has a specific attribute on it. And there's a bunch of different ways to do this. There are route rules in there, and the route rule is just basically any condition. So that could be in a header. It could be an attribute on the key. It might be something about the IP address or anything like that. So there's a lot of different ways to do the routing in there. Where could I get the JWT tokens? IBM, ISAM, or ping? Right. So how would you generate tokens from different places? So what I showed in here for the client authentication, the calls coming in, was a simple API key. You could also do a JWT, or you could do an OAuth token. The way that works is Apigee generates those tokens, and there's a policy in there that'll generate them, and it does it unconditionally. Usually almost always you're going to put a condition in front of that, and it will check with some third-party system. So that could be an HTTP call out. It could be something you do in a Java policy, but that's going to call out, check the credentials of the user, and then if they're approved, it would generate an Apigee token. Or you could completely delegate that to the backend system. There's a bunch of different ways to do that, but there's very nice integration with third-party identity management systems. So can we send the same traffic to legacy and new, but process new as a simulation to check the accuracy before switching completely? Yeah, absolutely. So in here, I've got a routing rule where it's switching between the two. There's also a policy in here that lets you call out to another HTTP service. So yeah, you could send it to two of them and then just throw away the answer or do whatever you like. But yeah, there's a lot of flexibility in terms of how you route and things like that. Let's see. Another question similar to that. Let me follow up on this because it's kind of similar. Could you do blue, green, or canary testing and route a random percentage of traffic? So yes, in here my condition is just if it's this specific application, I want to send it up to the cloud. You could also have a Java, JavaScript, or Python policy in here that just has a randomizer in there, and it would generate 1%, 5%, 10%, and then that would be it would set a flag, and then that flag is the condition for the routing. So yeah, that would allow you to do randomized testing and to kind of ramp up what you're going to be sending up to the cloud to make sure that it's okay. Let me look for a few more questions in here. We've got a lot of questions. Let me run through here. Thanks for all the questions. What about Active Directory, ADFS, or Okta support for Apigee Auth? Those are all supported too. So similar to how I answered earlier, you can integrate with third parties by calling out to them. Most of those folks that you listed on here have very nice APIs, so you can call out to those. If you look on community.apigee.com, you'll often find code examples for these, and a lot of people have done much of this. Can you call two back-end APIs in one call? Yes, you can. Oftentimes we'll want to build a composite API. I've got another webcast out on YouTube on exactly how to do that if you want to check that out. But yeah, you can do a service call out or use some of the coding functions, call two backends, assemble the answer, and then send that out. So it's a nice way to build a composite system. Any support or benefit in using Apigee for SOAP over HTTP? So yeah, I'm showing all JSON data in here in REST. Yeah, many of our customers have SOAP. So we're just speaking HTTP. There would be benefit of putting this in front of a SOAP service. You have the ability to reformat the request or the response as you see fit. You can do all the same things that I did in here. You're just going to be working in XML and SOAP. But you can do rate limiting. You can transform messages, dynamic routing, all of those same things. There's a longer version of this demo that I've done in the past where I allow somebody to set a request header. And inside that request header, they specify what type of response they'll accept, whether it's going to be XML or whether it's going to be JSON. So you could have it speak SOAP to legacy clients, and you could have it speak REST to newer clients. Are there any other equivalent products to Apigee? And I didn't put this one in here. Of course not. This is the best one on the market. So, in all fairness, do your research, take a look on our website. There is a nice Gartner report that goes over the competitors in this market. I thought they did a reasonable job of talking about what those are. IBM Resource Access Control Facility. Okay, support for authenticating users. I don't know that particular IBM system in detail, but what we've got in there, what we would need to do is basically talk to that system and find a way for it to approve a user. So if they have a Java interface for it or some way to talk to it over HTTP, it should be relatively straightforward to integrate. There is a link to the Gartner resource in your panel, so you can take a look at that, just following up on my previous question about competitors. What are the pricing plans and how much does it cost? Follow up with your sales rep. So there should be some resource links in the follow-up to this. You can follow up with the sales rep. If you want to see an in-depth demo, or if you want to talk to them about your specific use case and get some ideas of how it's priced, follow up with the sales rep for that. Okay, I'm looking for a few more questions in here. What about exposing ServiceNow, Salesforce, Workday? We do have some adapters for Salesforce on the back end there. It's something we're working on. For ServiceNow and Workday, they have nice APIs, and so check their documentation, and you should be able to talk to those. Can you do different rate limits for different partners? How is that done? So suppose partner A and partner B in here should be limited in different ways. How might we do that? Any of the policies that are in there, like rate limiting and stuff, I specified parameters by hard coding them in there. Those can also be variables, and those can be pulled off an API key or derived from anything else. If you saw in the trace utility, there's a whole list of variables in there. You can take any of those, and you can write a condition, and you could check if it's one or the other or greater than something or whatever you want to do in there. But programmatically, you can do rate limiting of different people at different rates. And this is something that's really cool because oftentimes we have different relationships with those partners, and we want to have different rate limits, different quotas, things like that. I converted everything to JSON. What about old clients who need XML? Yeah, you could put an accept header in there, and then you might conditionally convert to JSON or conditionally convert to XML if you're talking to the cloud service that only speaks JSON. So yeah, you could make sure your API is smart enough to respond in the right way based on what the client is asking about. Okay, a few more questions here. Does the backend legacy service auth, is that handled by Apigee? Let's say it's Active Directory auth, or can it pass through for an AD user? So a lot of times, there's all kinds of flexibility in Apigee to integrate with a variety of different authentication systems and authorization systems. We can do call outs to those. We could simply delegate to the backend application and pass everything through and let it handle it. And that works quite well too. One of the goals that I would advocate for a good API program is that all of your APIs have consistent security. And oftentimes that's going to be JWT or it's going to be OAuth, because that's what will make developers the most successful, because it's going to be consistent and easy for them to understand. It's going to be like what they see on the web. So what I would recommend is, if you've got 3 different systems in the back end that all have different authentication systems, you handle that between Apigee and that back end. And then the front end, you would use Apigee to handle the authentication there. And then you're going to call out as needed to those various systems to make sure somebody's authorized. And that's going to give you consistent security for all of the different people who are using this. Is there a limit on transformations performed on the API layer? There's no formal limit on there. What I typically recommend is there's what we can do in Apigee, and then there's what we should do in Apigee. I find that huge business logic type things, where you're going to be running lots of code and things like that, it's looking things up, I would tend to put that on the back end behind Apigee. Maybe it's a layer in front of what you've got running back there, but it's not an Apigee. You can write lots of Java code. You can do tons of transformations in there. Lightweight transformation between protocols or removing a field and things like that. Those are reasonable things to do inside of Apigee, in my opinion. So I would do those in Apigee and then push the more heavy lifting to the back end if it's going to be something that's heavy business logic. You're going to have code in either place, so it's your choice in terms of what makes more sense in your architecture. Okay, that's all the questions we've got for now. I think with that, we're going to go ahead and wrap up the webcast. Thank you all very much for attending today.